This is part one of Venus. We start with the key question: Venus, overview. Venus is the brightest natural object in our sky after the Sun and Moon, and also one of the least understood worlds in the inner solar system. Today, we start to change that. This is Venus, Episode 1. The core question is simple. What kind of world is Venus, really? And why has it turned out so differently from Earth? That question matters now because a new wave of missions is heading there this decade, and the answers could reshape how we think about rocky planets everywhere. Start with the basics. Venus is the second planet from the Sun, sitting about 108 million kilometers out on average, roughly 72% of Earth's orbital distance. Close enough to receive nearly twice the solar energy we do. It's also almost exactly the same size as Earth. Venus has a diameter of about 12,100 kilometers, compared to Earth's 12,700. Surface gravity runs at about 90% of what you'd feel here. On paper, these two worlds look like siblings. But here's the first thing to hold in mind. That similarity in size and position doesn't make Venus Earth's twin in any meaningful sense. It's a completely different kind of world. Why that is, that's what this series is going to unpack. How Venus moves is worth paying attention to, because it does something quite odd. It rotates on its axis extremely slowly. One Venusian day lasts about 243 Earth days, longer than its year, which comes in at around 225 Earth days. A day on Venus is longer than a year, and it rotates backwards. If you could hover above the solar system and watch the planets spin, Venus turns in the opposite direction to most of them. The Sun would rise in the west and set in the east. There's no fully settled explanation for why. Leading ideas involve ancient collisions or gravitational interactions that gradually tipped and slowed the planet's rotation over billions of years. That's an open question we'll come back to later in this series. Now, the surface. Most of what we know about Venus's terrain comes from radar mapping. The dense cloud cover blocks any direct optical view from orbit. NASA's Magellan spacecraft, which arrived at Venus in August 1990, mapped around 98% of the surface using synthetic aperture radar. What it found was a world dominated by volcanic plains, highland regions, vast lava flows, and a network of tectonic features that don't match anything on Earth. As far as we can currently tell, Venus has no system of moving plates. Instead, the crust may periodically overturn in large-scale resurfacing events, a process that would have repeatedly remade the entire surface from scratch. That matters because Venus's surface is estimated to be somewhere between 300 and 600 million years old, geologically young. Something major happened here. What triggered it, and whether that process is still ongoing, remains one of the biggest open questions in planetary science. Then there's the temperature. The surface averages around 465 degrees Celsius, hot enough to melt lead. What makes it stranger is how uniform that heat is. Dayside, nightside, poles, equator. The temperature barely shifts. The reason for that is the atmosphere. And it's quite a story, which is exactly where we're headed next time. Because Venus's atmosphere isn't just hostile, it's scientifically fascinating in ways that bear directly on how we understand climate across any rocky world, including ours. Next episode, what that atmosphere is made of, why it behaves the way it does, and what it might tell us about planetary evolution. The full Venus playlist is linked below if you want to follow this through from the start. And if careful, straightforward space science is what you're here for. Subscribing means you won't miss the next one. See you then. That is part 1 of Venus. In part 2, we explore the next key question. Subscribe so you do not miss it.